This is the review for the midterm exam. First question says, use the graph to determine the function's domain and range. Write the domain and range in interval notation. So basically, how do we find the domain of any graph? We look at the graph from left to right. So on the very left side, if you're wondering, is this graph really starting at the -10? Remember that I told you already once in class that if you do not see arrows at the beginning on the left side or at the end on the right side of the graph, unless you see a dot, you see a closed dot or an open dot at the beginning or at the end. If I do not see the open dot or the closed dot, that means that this graph is going to continue in an infinite way towards this direction. So let's assume that we have arrows here, and the same thing you're going to do if you see a problem that doesn't have an arrows, unless it has a dot, a closed dot, or an open dot, an open circle, then we're going to assume that it's going to continue. So domain here would be, starting on the left side, starts at -infinity because it goes to the left side in an infinite way. So it starts at some at some negative x coordinate, but we do not know which one, so -infinity. And then as we trace this graph from left to right, you can see that on the right side it's going to keep on moving towards the right side, towards positive infinity, towards the positive x's now. As far as the range, you're going to start from looking at the y coordinates of this graph, so meaning the y values, the y-axis, from bottom to top. So at the very bottom, this starts at 0 right here on the y's. Now the question is, should I use a bracket or should I use a regular parenthesis on the 0? You're going to use a bracket because you can see that this is passing right through that y coordinate. Unless you would see, the only reason that you would put when you see a graph actually passing through a certain either x or y value, but you're going to use a regular parenthesis on the number, it's going to be because you have an open dot here, an open circle, but we don't see that, so we are going to include the value of 0. Now, how far does it go going upward? Well, the highest piece from this graph is going to be over here on the right side, because the left side is lower than the right side. How high does it get? To which y value does it go, which is the highest of all? It's going to be up to 6. So from 0 to 6, do I include the 6? Yes. Unless, because all this horizontal little piece here has the same y coordinate all the time, 6. All these points in this piece have the same y coordinate. Unless I see an open circle, I don't include it, but I don't see that. So then here it would be B. That would be our answer. Okay. And question 2 says, let me move this. For the given functions f and g, find the requested function and state its domain. Write the domain in interval notation. So this is the requested function, f over g, right? So all I'm going to do is f of x, which is this function, over g of x, which is this function. And this is f over g. Then it says, so you can see that you can eliminate some of these choices by looking at which of these choices have the same division set up as the way that I did. F on the numerator, G on the denominator. So the first one, A, no, right? Simply because of that, it's flipped. Could be C, could not be B, so we're between C and D. So to figure out which is the right one, we need to find the domain of this composition, right? To find the domain, of this composition, of this combination, I should say composition. Composition is when you substitute one function into the other. Here we're doing a combination, not a composition. A combination of two functions is when you add two functions, when you subtract two functions, when you divide or multiply two functions. Substitution of one function into another one, that's a composite function, a composition, and that's a different thing from here to find the domain. So here, basically just see what is the domain of the function that I created here. How do I find the domain of a rational function? Because that's what this is. It's a function that looks as a fraction, right, where you have an equation divided by another equation. You're going to find the domain by setting the denominator equal to 0, and you're going to solve for x. So 3x equals 5. You divide by 3, and this is x equals 5/3. So I'm going to do a number line where I place the 5/3 right here. And so remember that for sure this line that I drew here is just to show you why the answer is going to be what's going to be for the domain. But in reality, when you're finding the domain of a rational function, of a function that looks as a fraction, automatically the number that you get here, it's the number that you're going to use to write the answer in the format that we are going to write it. But why is the reason that we are going to write it like that? Here it's the explanation. But you wouldn't have to do this explanation on the test, let's say. You're just going to do the solving of the denominator for x. Once you get that number, you're going to learn to write the answer in the format as I'm going to show you right now. But I want to explain why to you. Why is the answer going to be that? So if I test a value to the left side of 5/3, and you may be saying, what's 5/3? Put it into your calculator, and it's roughly rounded 1.7. So then what number can I choose to the left side of positive 1.7? You could easily choose 0. That's an easy number to deal with. And after 1.7, you could choose 2. So the only restriction, I'm going to write it here, restriction in the domain of a rational function, if you recall, we already went over this definition or this concept, is that you can never divide by 0. Division by 0 is undefined. It's something that doesn't have an answer. That's what this is. So in other words, I don't want to substitute a number into this x on top and into this x at the bottom and get a 0 on the denominator. That is the issue. Division by 0 is undefined. So I don't want 0 on the denominator. So no 0 on denominator. That's what I do not want. I can have a 0 on the numerator, and that's okay, but not on the denominator. So then, that was the purpose of me setting this equation equal to 0 and finding out which number, if I plug it into the x, which is going to be this one, when I put it into that x, this expression is going to give me 0 because I equal it to 0. So then, this number 5/3, for sure, it's a number that I cannot use as part of the domain, meaning that the domain is basically what x values you're able to substitute into the x or the x's of this function. So 5/3 is one that I cannot substitute. Okay. Now, why I could substitute any other number? Because I chose at random a number to the left side of 5/3 and a number at random to the right side of 5/3. If you plug in the 0 on the denominator, the only thing that you don't ever want to get on the denominator is 0, but anything else, it's fine. So if I were to substitute here a 0, 3 times 0 is 0, 0 minus 5, it's -5, and there's no issue with that. It's okay that I can substitute any number to the left side of 5/3 or smaller than 5/3, and it's never going to give me a 0. Same thing with 2. I chose 2 as a representative of all the numbers that are to the right side of 5/3, that are greater than 5/3. So if I put a 2 here, 3 times 2 is 6 on this x on the denominator, and 6 minus 5 is 1. So there's no issue with having a 1. The only number that if I plug in here, it's going to give me 0, it's going to be this one. Look, 3 times 5/3 minus 5. Once we learn a shortcut where these two cancel out, and then you end up with a 5. I know here cannot really tell that was a 5, but it was a 5. Let me make this smaller. So then what's 5 minus 5? 0. And that's exactly what I said that I don't want to have here. That's why that's the only number that I cannot use for the x, because it's going to make my denominator to be 0. So how do I write my domain? My domain, it's going to be that I can use, looking at the number line that I drew right here. I can use any number to the left side of 5/3, starting since the negative infinity all the way up to 5/3. I'm going to use this regular parenthesis because I want to exclude the 5/3. Union from 5/3 all the way to infinity. So with this parenthesis, I'm excluding the 5/3. And I do not want to include it. Why not? Because that number cannot be part of the domain, because that number is the one that makes the denominator to be 0. If you put a bracket, you're including it, and then therefore you're defeating the purpose of the whole solution of this problem. Okay, bracket includes, regular parenthesis excludes. So that would be the domain. So now from these two answer choices, obviously C cannot be right. The correct answer would be letter D, because this one has a different domain. This is the one that has the same domain as the one that I did. So that's the answer for question 2. Question 3, for the given functions f and g, find the indicated composition. Okay, now here it is, the other concept that I was talking to you about right now. Composition. Look at the way they're presenting the composition, or how are you supposed to perform it. This says that we are going to substitute f of x into g of x. So I'm going to say, okay, g of x is equals to, I'm going to copy g of x, 1 over x. So into every x, I'm going to substitute f of x. And f of x is which function? This one right up here with the square root. So in my next step, f of x is going to be the square root of x minus 3. Okay. So then that would be my composite function. Now here they're not asking me to find the domain, that's all they're asking me to do, so I could practice with you how to find the domain of this, but that's not the question, so I'm not going to do that. Maybe there's other questions that will ask us for that. So this would be the solution. So 1 over the square root of x minus 3. Oh, and I didn't see something. This one, this g of x, had a negative right here that I forgot to keep on bringing down and bringing down every time. So there's a negative here, okay? Sorry that I messed up. So then negative 1, this one, right? Negative 1 over the square root of x minus 3. That would be the answer. Sorry, because I didn't see the negative. Okay, here, this is using the same instruction from 3, finding the composite function as indicated, using these two functions now. So then, here they're telling me to do f of g of x. So, what is this meaning? Well, I have to substitute g of x into every x of f of x. So, f of x is 7 over x minus 3. So then into this x, we're going to substitute g of x into every x of this function. Every x will become whatever g of x is. So then what's the g of x function? It's this fraction 4 over 7x. 4 over 7x. So then we have to simplify this, because if you look at this answer choices, none of them look like this. So I already showed you once this strategy, that what we want to do is get rid of this small fraction, and we're going to multiply by the denominator. But whatever the denominator of this fraction, whatever I decide to do on this fraction, I have to do it in the 3 terms, the one on top and the 2 at the bottom, each of them. So then this would be 49x on the numerator. Remember that the purpose of doing the multiplication times 7x is because I want to cancel this denominator with this expression. So then this is what I end up with on the denominator, and this would be my answer. So now let's see. And this cannot be simplified any further. If I could do anything with this, is if you see the 49 on top, the 4, the 21, if these 3 numbers would be divisible by a common number, I would divide them all just to make them smaller, the 3 of them. But in this case, it's something that's not possible. So 49x over 4 minus 21x. 49x over 4 minus 29x. So this would be the same as what we did. Yes. 5 says find the requested value. So this one is a very simple question, but often we may get confused with this. So it says f of negative 7 for f of x equals these 3 equations. These 3 equations have their restrictions. This is a piecewise function. This is that kind of function. So then f of negative 7 means that this was an f of x, right? Or that's what this number is representing, an x. So I have to be able to read these three restrictions for the domain of each of these 3 equations in this piecewise function. So then it says in here on the first one, what kind of x's am I going to substitute? Let me get my highlighter. Into this x right here. Well, you're going to substitute x's that are less than to 7. I was going to say or equal, but no, it's just less than 7. So here it says less than 7. What's less than 7? X. They're talking about what numbers are you going to be able to substitute into this x. Numbers that are less than 7. Then we also have get another color, this one. Into the x of this function, what kind of x's are you going to be able to substitute? Only if the x's are between 7 and 11, then you're going to be able to substitute them there. So between 7 and 11. That's the kind of x's you're going to be able to put into this function. Lastly, this 9x, only if you're going to put that, you're going to substitute a value in here for this particular x, only if that x value is greater than 11. So, greater than 11. So, the number that I want to substitute, it's a negative 7. The question is, where does this negative 7 fit? Into which of these 3 descriptions on the domain, let's say. So is negative 7 a number that is less than 7? Yes. So far I would say I would substitute it into this first equation, but let's keep on reading the other ones too anyway. So is negative 7 a number that's between 7 and 11? Nope. And if you need to, so that you can do a graphical representation, like this first one, what this is saying is x is less than 7. So let's say that this is 7. So numbers that are less than 7 are going to be going in this direction, right? Numbers that are less than 7. So x less than 7, that's what it is. For this one in the middle, it says that the x has to be between 7 and 11. So let's say this is 7, and let's say this is 11. So the numbers that I'm talking about are numbers that are between these two. That's what this is. That's what this symbols mean. And then for this last one here, I'm gonna do it here because I almost don't have space. It says, let's say that this is 11. Numbers greater than 11 are gonna be going to the right side. Okay. So then this negative 7, maybe it's easier for you to see where this belongs. Negative 7, is it a number that is less than 7? Yes, because eventually numbers that are less than 7 are gonna be 6, 5, 4, 3, 2, 1, 0, but then negative 1, negative 2, so eventually negative 7, yes, it's to the left side of 7. Is it between 7 and 11? No, definitely not. Negative 7 is going to be somewhere to the left side of the 7, right? And then greater than 11, to the right side of 11, I don't think we can find this number. So the only domain where this negative 7 value fits is going to be into the first domain. So you're going to substitute it into the first equation, into 5x plus 1. You copy all the equations. And into this x, you're going to substitute this value that is given to you. So 5 times negative 7 is negative 35 plus 1, negative 34. So f of negative 7 is equal to negative 34. This is the answer. So when you substitute an x, this is the answer, which is a y value, by the way. So right here, this would be our answer. Okay. So that's question 5. Question 6, graph this. I felt last time on the test that there was a confusion between 5 and 6. This is evaluating a piecewise function, solving, just plugging in a number, right? But before you plug in the number, you have to be able to read these 3 inequalities. If you don't read them, if you don't know how, then you can't. How are you going to know where you're going to substitute the number? Because you're not going to substitute it in the 3 equations, only into one of them. This is graphing a piecewise function, not just putting in a number into an x. Here what you want to do is graph. So then, okay, how do I graph? You're going to graph by pieces. You're going to do this graph first, and then we'll do the graph for this other one. Now, the only thing is you're going to consider what, oops, sorry, and I keep on putting the same thing. You're going to consider the restrictions, these 2. So here it says that you can only use x's to graph on the first function that are less than 0. This one says x's that are greater than or equal to 0. Okay. So think of a number line. Here you're saying x's that are less than 0. So it's going this way, right? And here greater than or equal to 0. So 0 is right here in the center. Now greater than 0 is going to be going this way. Here, if you don't have an equal sign, that means this would be the symbol that we use if we're writing an interval. But in the graph, that means you're going to put an open dot. Here, this equal sign would mean a square bracket or would mean a closed dot on the graph, right? You're not going to put the brackets or the parentheses on the graph. You're going to put the dots. So what x's am I going to choose? On the test that you just took, everyone was choosing whatever x's, not even paying attention to the restriction. And most of you were getting that question wrong because of that. So this is your guide to know which x's you're going to choose for creating your table of values. So can you start with 0 even though technically x cannot be equal to 0, only less than 0? Yes, it's fine. Start with 0, and on the graph you're going to put an open dot. Actually, you want to start with that one to show that open dot on the graph. So what else is less than 0? -1, -2. I mean, you could choose more numbers, but that would be enough. So 4 times 0 is going to be 0 plus 8, 8. 4 times -1, it's -4. -4 plus 8 is 4. 4 times -2 is -8, and -8 plus 8 is 0. Okay, so I just basically substituted for the x each of those three numbers, and that's it. 0 and anything greater than 0, so let's put a 1 and a 2. So 0 squared is 0, times 4 is 0, 0 minus 2, -2. Oops. If you put a 1 into this x and you raise it to the second power, 1 times 1 is 1, 1 times 4 is 4, 4 minus 2 is 2. 2 times 2 is 4, 4 times 4 is 16, and 16 minus 2 is going to be 14. Okay. So then what we do is plug the numbers here. So then, don't know if, yeah, I can make this one bigger. So, and then make this a little bit smaller. So, for the 0, 8 point, for that point on the graph, I'm going to put an open circle at 0, 8. I put an open circle. I don't fill it inside, okay? Because of this symbol, because I don't have an equal sign. Then I'm going to put a dot, and that's going to be a regular dot at -1, 4, at -2, 0. Okay, and this is going to be a line. It's a linear equation because the highest exponent on the x from the equation is a 1. So let me use this other color. There. So there's my line. And here are my dots. Okay, so the other one is 0, -2. Here I'm going to put a regular dot at 0, -2, 1, 2, and 2, 14. 12, 13, 14. So let's pretend here's our 14. Now, the square, the exponent 2 on the x, that tells me that this is a quadratic function. If you look at your formula chart, you're going to realize that the quadratic formula, but quadratic function, sorry, both start with an F, right? Function. What's a quadratic function, or what's the shape? It's like a U shape. But this one, so this one, don't do it as a line. It's supposed to be curving, and just do it as best as possible. Here, let me raise this little piece, and little by little it's kind of getting wider until it's able to pass through here. But it's not a line. I know it looks as if it's going to be connected as a line. It's not going to be, and I can tell you because of the exponent 2. This little exponent right here, it's the one that makes me think that it's this kind of function. Okay. here is the answer for this question 6. Question 7 says, if the function is 1 to 1, find its inverse. If not, write not 1 to 1. Okay, so a function that is 1 to 1, if we were able to see the graph, if we would be able to see the graph. I don't know if you recall this, but I showed you this would be like the shortcut way, let's say, to see if it is a 1 to 1 first of all. So let me show you. I would put it on the y equals, I would graph it, and if I am able to draw a horizontal line through the graph, and this horizontal line never anywhere touches or intersects the graph in more than one point, and I don't think this is going to be the case. Anyway, where I draw a horizontal line, and I can do as many lines as I want, never the graph is going to touch with the same horizontal line more than once the graph itself, not the coordinates, just the graph. So then this is a 1 to 1 function. Now it says if it is a 1 to 1, find its inverse. And to be honest, this kind of questions, if there is one on the test, the question is not going to be to check if the equation is a 1 to 1. They may present to you a graph and say, check if this graph has an inverse. And if it has an inverse, it has to be a function that is called a 1 to 1 because of the same thing, right? But here the question is kind of tricky, because that's not really the question to know if it is a 1 to 1. It says if the function is 1 to 1, find its inverse. In this kind of questions, it's a given that if they're asking you to find the inverse of an equation, the graph has to be a 1 to 1. It's going to be given to you already like that. I just did this for you to check or to recall this concept so that you don't get confused and you're like, and how do I check if it is a 1 to 1? Basically, you just graph it, pass a horizontal line through it, and that's the easiest way to check if it is a 1 to 1. So now, how to find the inverse? Okay, remember that there were several steps to find the inverse. So the first step was that instead of writing f of x, you're gonna write a y, and you're gonna switch around your x and your y from place. Okay. So first step was to replace the f of x by a y. The second step was interchanging your x and your y from place. And then the third step starts here, where we are going to start solving for the y. Because every time that you interchange your x and y, your equation is not solved for y anymore. So let me rewrite this. And the first thing that I'm going to do is move the minus 5 to the other side. So you end up with x plus 5 equals this. Divide by 8. So y to the third is equals to x plus 5 over 8. Then to leave my y by itself, I had to do the cube root on both sides. So the cube root and the 3, they both cancel out. And here is my inverse function. I'm gonna flip this around completely. Okay, so instead of the y, I'm going to put f inverse of x, because remember that this is the way that we represent the inverse of a function. It's not necessarily that the minus 1 there is an exponent. It's just an abbreviation to say the inverse function of x. So then let's see which one from here looks the same. So it would be was x minus, no, x plus 5, right? So it would be this one. Okay. Number 8 is, we're going to use the same instruction as in here. We're not going to check if it is a 1 to 1. It would be a 1 to 1. We want to find the inverse of this. So this function has a restriction, though. That's the only thing you need to be careful with. So then the first step is going to be change the f of x to a y. Second step is going to be switch from place, or interchange from place, your x and y. And so here also, on the restriction on the domain, this is the domain, right? But it was the domain of this function, of the original, the given one. Well, now this became the range. The range of the function you're going to solve for y right now. You're going to find of the inverse, the range of the inverse function of the original, right? So then, how do I solve for y here? I'm going to rewrite this to do this in the next step. I need to get this y outside of this square root, and the only operation that's going to cancel the square root is going to be raising that side to the second power. So then, I bring down my x squared, I bring down the y plus 2, I subtract 2 from both sides. So y is equal to x squared minus 2. Let's do what I did on the other problem where I flip this around. So I say the inverse function of x is equals to x squared minus 2. So then, sorry, I put a line there unintentionally. So which one is that function? X squared minus 2. What happened here? Oh, I see what I did wrong. I'm gonna highlight this for you. This one had a minus, and I put in here a plus. So this should have been a minus all this time. This, let me put it with this color, minus, 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 minus. So when I did this, when I moved this positive 2, which was supposed to be a negative 2, this was supposed to be plus and plus, therefore this is a plus, and so here also this, just put a plus in here. So x squared plus 2 was the answer, not minus 2. I was like, why is there nothing like that? X squared plus 2, and this is, okay, so I need to look for, is there only one like that? Oh yeah, there's only one like that anyway. Okay, but if you're like, and how do I come up with the x greater than or equal to 0? Well, this is the domain. The domain of the inverse function of x. So one thing you could do to figure out that, the quickest way, the fastest way you could do it, it's graph this x squared plus 2 and even though here they're not asking me to graph, but I mean I don't see another way of doing this, but okay, so this is the inverse function, right? And if we would say, and what's the domain here? Well, you're going to tell me the domain is negative infinity to positive infinity for this one, which is the same as this. And that's correct. Yet, why here, the domain of this inverse, it says that it's something else, that it's not that. The reason for the domain being like this is because the original given function had a restriction. Let me grab that one. Square root of x minus 2. And remember the concept that once we said that whatever the domain on the original function is, that's the range on the inverse function, right? And that's what we said with this. This is the domain of the original, so that when I switch the x and the y became the range on the inverse. But here I want to know the domain of the inverse. So then whatever the range of the original is, which was the original, the square root one. So this second one that I drew, whatever the range of this one is, that's the domain of this one, because we're going to erase one piece of this one that we're not supposed to have here. So what's the range for this piece right here? Let me take a screenshot and add it here. So the range for this one, which is supposed to be f inverse, not f inverse, the original, sorry, the original f of x. This was the original, so this one, square root of x minus 2. The range here is going to be starts at 0 and goes up to infinity. Okay. Which this written in set builder notation, 0 and any number greater than 0, so it's x greater than or equal to 0. Okay, that's, and I should say, I don't know why I put an x if I'm talking about the range, right? This is supposed to be the range of the original. So in reality, this becomes the domain, but on the inverse. So the domain here, it's going to be the same thing, but instead of with a y, we put it as with an x. Meaning that here, the domain of this one, because this one is supposed to be this one, this is the f inverse of x, has to be from 0 to infinity. So this is the only piece of graph that is supposed to be the inverse of this one. That means that it's like if this other piece does not exist, right? We ignore this piece. Okay. Because remember that an inverse function, it has to be a reflection across the line y equals to x. And the only way that these two are a reflection across each other is respecting the original domain given by this, using that as the range of the other one, and based on the range of the original, coming up with the domain of the inverse. Okay, so that's the reason for the domain here. But this question, if it is a multiple choice, it was a given that as soon as you got your inverse to be this, and no other answer choice had that same equation as that one, only this, it had to be this the answer. But if you're wondering about this, that is the way that I would figure it out. I would get the domain of the inverse by figuring out what is the range on the original. It was only given the domain of the original, but I came up with the range also. Okay, so that would be that question. This one is the same thing, I guess, find the inverse, right? So then this is the function. So first step is putting a y instead of the f of x, interchanging x and y from place, and finding a way to solve for y. So what do I do to solve for y? In my next step, remember that I don't want to have fractions, right? When I'm trying to solve an equation for a particular variable, and that variable is on the numerator or denominator, whatever the case is, I'm going to multiply both sides by that expression on the denominator. And so here I'm going to get xy plus 4x equals to 8. Here I'm going to factor out the common thing. I'm going to use greatest common factor here, GCF, from this 2, which is this. X times y is xy, x times 4 is 4x. And then since x is multiplying times, oh, you know what, here? I didn't have to do this, because I'm not trying to solve for x, I'm trying to solve for y. So there's only one term that has a y, so what I'm going to do is isolate that term that has the y by moving or sending the other term that does not have a y by sending it to the other side. So xy equals negative 4x plus 8, or 8 minus 4x, whatever you want to write, the order doesn't matter. And then since x and y are multiplying together, divide by x. And this would be my inverse function. Now, if you're like, can I cancel the x? Because I know we want to do that. No, you can't, because there's an addition operation here. You could only cancel x's if on the numerator, where you have more than one term, the negative 4x was multiplying times the 8. Since it is not like that, we cannot cancel the x's. So let's see which answer choice is like this one. Negative 4x plus 8 over x. So the first one, the very first one. Question 10 says, how can the graph of f of x equals negative 4x to the third plus 2 be obtained from the graph of y equals x to the third? So this is talking about transformations. So let's say that this is the original, the parent function, the given function, or however you want to call it. Original. How do you know which one is the original? The simplest one, the shortest one. Okay, so they want to know what changed from this to this. I know, first of all, the y and the f of x are going to say that's one thing that's different. Yeah, but that's not so much what the focus is. The focus is going to be two things. Actually, three things. This negative has a certain meaning. This 4 has another meaning. And this 2 also has a certain meaning. Okay? So, what's the meaning of this? This is talking about section 2.5 transformations. So, this negative, when I have a negative in front of a, or let's start by, before I get to the negative, let's start by the 4. When there is a number in front of the function x to the third, or in front of, right in front of the x, there's going to be a vertical stretch by a factor of 4. You may look this up in your packet of section 2.5 or look at the formula chart that you have. This 2 is a vertical shift 2 units up, and the negative means a reflection. Remember that depending where the negative is, if it is a reflection with the x-axis or with the y-axis. This is a reflection over the x-axis. When the negative is right in front of the function, it can say that it's right in front of the function x to the third or in front of the x, right? Although there's that 4, but in front of the function x to the third, then it's a reflection over the x-axis. So here I basically gave you already the answer. Okay, it's just a matter of recognizing. So stretch it vertically by a factor of 4. That would be this one in green. Reflect it across the x-axis because of this negative, and shift it 2 units upward. So that would be the one. The other ones have something that's not right when you read. Okay. So more than anything, you need to figure out this by looking at the chart on the formula chart, at the little chart of transformations. Okay. This one is similar. It's almost the same. So let's see what are the differences here now. Okay, so I see two things here. This is one thing, this is another thing. So the square root is no transformation. It is just for us to know that to preserve the same shape, right? The square root function is the square root function. So the difference from this original to this one, to this transformated version, it's that we always want to start from the inside, right? I always tell you that. So this means that there was a horizontal shift 8 units to the left. And this negative here means that there is a reflection about the x-axis. How do I know? Look at your chart in the formula chart that you have for transformations, and when there's a negative in front of the function, in this case in front of the square root function, it's a reflection over the x-axis or about the x-axis. So what answer choice would that be? First one says shifted horizontally 8 units to the left. Okay, that seems correct. But it says then reflected across the y-axis. That's not correct. B, shifted horizontally 8 units to the left, reflected across the x-axis. So that would be the one. B. Oops. Find the x-intercepts, if any, for the graph of the quadratic function. Okay, so what can you do here to find the x-intercepts? One option could be factorization. Another option could be quadratic formula. You really have, since the start, the two options. You could use any of the two. If, let's say, you try factorization and it's not factorable, then you should use the quadratic formula. But even if it is factorable or not, and you decide to find the solutions using the quadratic formula, even if it was factorable, it's okay. You'll get the same answers, the correct answers. Whatever you decide to do is correct. Let's try to see if it is factorable. And if it is not factorable, and we use the quadratic formula. But honestly, you can choose to start with whatever method, and the answer is going to be correct. It's just that if it is not factorable, then that means that I just wasted my time, and I'm going to have to use the quadratic formula anyway. So okay, this is a trinomial where we put the equal 0. Where a is a number greater than 1. So if you recall, those trinomials are always having some extra steps compared to the trinomials where the leading coefficient here in front of the x squared is a 1. Okay, so what I'm supposed to do is say 7 times 3 is 21. So I list 1 times 7. All the numbers that multiplied together, sorry about this, give me, I was thinking ahead of myself, I don't know. Then multiply together give me 21, which are only these two. 1 times 21 or 3 times 7. Added together, they need to give me 12. So I don't think that's going to work. None of this, 1 plus 21 obviously is not 12, 3 plus 7 is not 12 either. So then this is not factorable. So this is what I'm telling you. If it is factorable, good. But if it is not, I just wasted my time. And since the very beginning, I could have started finding the solution with this. Because after all, I mean, what they're asking me here is find the x-intercepts. Okay, find the x-intercepts. So find the solutions. Solve this equation for x, right? So one way of finding the solutions for x is solving for x through factorization, but if it doesn't work, then use the quadratic formula. So, and this is over 2a, right? So what's a, what's b, and what's c? 7, 12, and 3. So negative 12 plus or minus b squared, which is 12 squared, minus 4 times 8 times c. So times 7 times 3 over 2 times 7. Twelve times 12 is 144. Negative 4 times 7 is negative 28. Negative 28 times 3, it's negative 84, so minus 84, right? 2 times 7 is 14. Negative 12 plus or minus 144 minus 84, 60. Now, 60 doesn't have a perfect square root. There's no number that if I do this number times this number, that answer is 60. But looking at the answer choices, nothing is like what I got. So that means that 60 could be factorable in a way that I can break this number into the multiplication of two numbers where one of them has a perfect square root. So here is one strategy that you can use to simplify this. Okay. You're going to make a list of perfect squares. What are perfect squares? Perfect squares is when you start with the first integer and you raise them to the second power, right? 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. You're raising them to the second power, multiplying these integers by themselves, these consecutive integers by themselves twice. So 5 square is 25. 6 square is 36. Where am I going to stop? I'll see right now. You just want to make a list of, I don't know, the first 10 or something like that. Wherever you would like to stop at, it's okay. But I'm going to tell you, I'm going to stop here, okay? You could do always the first 10, the list of the first 10, if you want. Anyway, what am I looking for? I'm looking for which of these numbers that are already square. So I'm looking at the list after the equal sign, the 1, the 4, the 9, the 16. Which of these numbers is a number that 60 is divisible by? Now you may find that 60 is divisible by several numbers from this list, more than one, but you want to choose the greatest number from this list that 60 is divisible by, that 60 can be divided by, the biggest one. So obviously I know 60 is divisible by 1. 60, is it divisible by 4? Yes, it's divisible by 4. But the question here is, are you sure that's the greatest number? I don't know, let's see. 60, could it be divided by 9? No. Is 60 divisible by 16? No. 60, is it divisible by 25? No. 60, is it divisible by 36? I don't think it's going to be. And you can keep on trying the rest. By 49, those are too big anymore. So 60 is divisible by 60. Obviously, it's not going to be divisible by 64, right? I shouldn't even try that one. The only number that I found that 60 is divisible by is 4. From there, I tried a few others that are after that number, that are greater than that, and nothing is divisible by that. And then I should really stop, because 60 is between 49 and 64. So I really need to look at all the lists before where you find this number 60 being between these two integers. So I identify in between which two perfect square integers is that number. It's between these two. Okay, so look at the list prior to that, before that, and then choose what's the greatest number from that list that 60 is divisible by, and the biggest number that is divisible by is 4. Okay, so then you're gonna say negative 12 plus or minus, what are you gonna do here? So you know that 60 is divisible by 4. Let me put it again here. 60 divisible by 4 is 15. That means that 4 times 15 is 60, right? Obviously. So then 4 times 15, it's another way to write 60, but in factor form. That's what I was doing. I was trying to break down 60 into two factors, two numbers that multiply together would give me 60. Negative 12 plus or minus. What are you supposed to do here? 4 has a perfect square root, 15 does not. So then you're going to factor out the number that has a perfect square root. You're going to take the square root of that number. What's the square root of this one? It's 2. Right? You take it outside. You don't have to leave it anymore inside of the square because you already did the square root of that number. The 15 that doesn't have a perfect square root, leave it inside. Okay, so what's going to happen now is that this number, and this number are the three of them are divisible by a common number. All of them are divisible by 2. So you're going to divide by 2, divide by 2, divide by 2. There's no bigger number that can divide the three of them. And you can only do this, and 2 divided by 2, it's a 1. So I'm not going to write the 1 here at the front of the square root. You assume that there is a 1 after dividing this 2 by 2. You may write it if you want, but anyway, you're not going to see it on the answer choices, and you're going to be all confused. So this would be my two solutions. One is negative 6 plus the square root of 15 over 7, and the other one is negative 6 minus the square root of 15 over 7. So either this answer or this answer separately is acceptable. Both are correct. So now, negative 6 plus or minus the square root of 15 over 7. Okay, you can see that's one of the solutions. That's one of the x-intercepts. Okay, so then, because you're like, why is it written like this? I was even wondering. Don't think that this is one solution and this is another one. This is, they're just not writing the entire answer as it should be written. This is one x-intercept. This is another x-intercept, but with a minus there, not with a plus. Over 7, comma 0. So these are the two x-intercepts that I got here at the end, right? This one and this one. Okay. So then this is what the answer is going to be. Okay. So finding the x-intercepts, it's basically putting your y equal to 0, but your y was already here equal to 0 since the very beginning. So all I need to do is find the x's, find the solutions. Since I tried factorization, it wasn't factorable, I tried the quadratic formula. But you could have started with the quadratic formula since the very beginning. So you can see that this simplification that I showed you here is something that you need to know. This is not even college algebra, this is from basic algebra, this factorization or breaking down this number that doesn't have a perfect square root. This is what you do when you are doing the square root of a number that doesn't have a perfect square root. You break it down in using this method, which is factoring a non-perfect square root number. Okay, I'm going to put it here. Factoring a non-perfect square root number. Okay, that's what you're doing here. Okay, this one. Find the y-intercept for the graph. Okay, so this one's easier. Way easier. To find the y-intercept, remember that you're supposed to set your y equal to 0. So this is my y. So I'm going to put 0 equals 5x to the third minus 3x minus 8. Now, sorry, I'm doing as if I'm finding the x's again, the x-intercept. This is y-intercept. So for the y-intercept, you put a 0 on the x's, right? So, and the result is going to be your y-intercept. So this, we can already call it a y. And here, I'm going to put the zeros already. 0 squared times 0. So this is going to be a 0. 0 squared is 0 times 5 is 0. This is going to be a 0. So you're basically going to get negative 8. That's the y-intercept, which written as an ordered pair, you put a 0 on the x, and this is your y-coordinate. So it would be D. Next question, 14, find the range of the quadratic function. Okay, how would I find the range? I'm going to do it by hand, and then I'll do it with the calculator. It's a multiple choice test. Use the calculator as much as you can. So I would want to, if I don't have a graphing calculator, how I can figure this out. So hopefully you will have one so that you can use the shortcut that I'm going to show you. I would need to imagine that I graph this. And how do I graph it? I do as if I'm going to find the vertex. So how do I find the vertex of an equation that it's in this format? You're going to find it in 2 steps. What's the b going to be? 2. What's the a going to be? 3. So negative 2 over 6. So negative 1 over 3 if I reduce this by dividing by 2 by dividing by 2, right? Then this negative 1 over 3, I put it where? Into every x in my original function. So this is going to be 3. A negative times a negative, it's a positive. 1 times 1 is 1. 3 times 3 is 9. I could have multiplied already here. A positive times a negative, it's a negative. Imagine you put this over 1 and you multiply across. So 2 over 3 minus 3. Same thing here. Put this one over 1, multiply across. So 3 over 9 minus 2/3 minus 3. So first of all, I could reduce. Divide this by 3. So it turns into 1/3 minus 2/3 minus 3. I could combine this, which is going to be, oops, not 3. 1 minus 2. On the numerator, it's negative 1 over 3 minus 3. This number, to change it into a fraction in terms of thirds, what you're going to do is multiply these two numbers. The integer times the denominator. So there was a minus, right, first of all. So 3 times 3 is 9, 9/3, because that's what you're trying to turn this 3 into a fraction written in terms of the same denominator as the other one. So you copy the denominator. So it's going to be negative 10/3. Okay. So the vertex would be at first, what was it? Negative 1/3, comma, negative 10/3. This would be my y, let's say, right? So negative 1 over 3 is going to be negative 0.3333, okay? Negative 10 over 3, negative 3.333. So roughly, my vertex would be at negative 0.33 with negative 3.333. Let's say more or less is right there. My parabola in this point, well, I'll put the point right now. My parabola is going to open upward. If you remember the number in front of the x squared, the a, that tells me if it opens up or down. If it is positive, it opens upward. So from here, I don't care what the x-intercepts are going to be, okay, because that's not the focus or the emphasis here. We're not finding x-intercepts, we're not finding y-intercepts, anything. Okay, so this point, which is negative 1/3, comma, negative 10/3, which is the vertex, I'm going to use this information to write what the range is. The range is starting at this y-coordinate right here, bracket, negative 10/3, and then this graph goes upward to the positive y-coordinates. So that would be letter B. Yep, that's what that is. What's the shortcut to this? Obviously, multiple choice test. Use the calculator. I would put 3x squared plus 2x minus 3. Now, the only thing with this is you see the vertex right here. And look at the kind of x and y coordinates that the vertex has. They're fractions. So, what way could you figure out what the vertex is? Maybe, let me see. Okay, so this is one way of using the calculator to figure this answer out. You have the graph, you go to second trace. This is a minimum. I don't know if you recall, but we already went over this. That this is a minimum. When there's a U opening upward, we know the minimum. And even though they're not asking me for the minimum, that's the only way to figure out these numbers with the calculator. So you click on the minimum, left bound. Okay, so I need to put myself somewhere on the left side of the point that I want to find out what their values are for that point. So I enter and it says right bound. So now I'm going to move somewhere to the right side of that point that I want to find. And then I click again. So these are the same decimals that I got when I put into the calculator these two numbers, if you recall. Let me show you now. I don't want to get out because then I'm going to erase the point. But negative 1/3 is negative 0.333. Negative 3.33 is the negative 10/3. Okay, so that would be the shortcut, and then say, okay, what's the range? Okay, from this y coordinate upward. Okay, so from this number. It's just you're going to have to put in these numbers into the calculator to see which one is negative 3.333, okay? And so that's how you get to this answer. So I showed you algebraically, because if you don't have a calculator or you don't know how to use the calculator very well, well, here is, you're going to have to do the basic way by hand. Okay. 15, question 15. Find the axis of symmetry of the parabola defined by the given quadratic function. Find the axis of symmetry. Okay, axis of symmetry is in any parabola. Remember, the axis of symmetry is this line that goes here through the middle, right? Or even if the parabola is open and down, there's a parabola here. I mean a parabola, a line that cuts this into two equal parts. So if I want to find the axis of symmetry, it's like finding the x-coordinate of the vertex. Because if I find of this point or this point the x-coordinate, right, if I find this, I don't care what the y is, I just want the x, because the equation for this line is going to be x equals something, x equals some number, and that number is going to be the x-coordinate from the vertex. So then negative 12 over 2 times 1. So negative 12 over 2, so x is equals to negative 6. That would be the equation of the axis of symmetry. Okay. If you recall, you're like, where are you getting the b and the a? Well, just remember that this is written ax squared plus bx plus c format. Okay. Complete the following. Find the x and y intercepts. Determine the multiplicity of each zero of f and graph it. Okay, so to find the x and the y intercepts, to find the x intercept by hand without using the calculator, I'll show you with the calculator right now. I'm going to put a 0 where on the y. So instead of the f of x, I put a 0. And so I figure out a way to solve for x. Each of the factors, each of the things that are multiplying times each other, I'm going to set it equal to 0, and I'm going to solve for x on them. So I do the square root, I do the square root, so this is x equals 0. Subtract 3, so this is x equals negative 3, add 3, so x equals 3. So then these are my three x-intercepts. This one, and this one. Multiplicity for them. Multiplicity is 2, right? The exponent. And because the multiplicity is 2, because it's even, the graph has to touch and turn around. F of x touches and turns around at x equals 0. These other two x-intercepts both have an exponent of 1 here on the outside of the parenthesis, even though I don't see it. So then for both, the multiplicity is 1, which is an odd number, which means that the function f of x crosses the x-axis. Okay, so I found this would be I, right? This would be the answer for the second part. And for the third part, graph it. Okay, so then one thing they're not asking me here, but I need to know that. I need to know what's the end behavior if I want to graph this by hand. So, end behavior. I need to know the degree and the leading coefficient. So, x to the second, x to the first power, and x to the first power. I'm going to copy those x's and multiply them together. So x to the second times x, right? So my degree is going to be 2 plus 1, 3, plus another 1, 4. Degree is 4. The degree you classified as an even or as a not degree, it's an even. The leading coefficient, it's going to be this 1 times this 1 times this 1. I mean, it's just going to be 1. So this is going to be positive. So if you recall, what's the combination of an even degree with a positive leading coefficient? Then my graph is going to have some endpoints that are going to be pointing both upward. Left and right sides both right. So okay, when I'm trying to do the graph, I'm going to plot points at the x-intercept 0, -3, and 3. And since the graph is supposed to be on the left side pointing upward, and through 0 it's supposed to touch and turn around, it says. Okay, and then somewhere it's going to turn, I don't know where. I just know it's going to turn, it's going to cross, and somewhere again it's going to cross through here. And that's it. And that would be my graph. Obviously, shortcut if you have calculator, you put it on the calculator. Can you do that? Yes. In a multiple choice test? Sure, why not? Oh, sorry. I'm like, why doesn't it look the same? Okay, I was just putting if it's crossing or touching as I was reading the multiplities, but I wasn't paying attention to the values. It's going to take a while to erase it. There we go, there we go. Okay, so that part was right in the sense that, okay, the graph had to be pointing upward on the left. So, but this, I was reading like the multiplicity touches, okay, so I was making a touch here at -3 when it was supposed to be touching at 0, not at -3. At -3, it says that it's supposed to cross the x-axis. So you make it pass through this x-intercept and you make it cross the x-axis. At 0, it's where it says that it's going to do this turn, it's going to touch, and it's going to turn again. And then later, it's supposed to be curving again and crossing through x equals 3, because that's what I was saying here. At -3 and 3, it's going to cross the x-axis. That's what's doing here. And at 0, touching and turning around and pointing upward. So now it matches what I had here. When I saw it, I was like, what did I just do? Sorry. Okay. So that's what it is. So now this matches this information. And I'm telling you, if you don't have a graphing calculator, even though they were not asking me about the end behavior, I would need to know this information to know how it's going to end on the left and on the right. Use synthetic division to perform the division. So synthetic division. Okay, first of all, something that I see is that this equation on top needs a lot of zeros. Okay. 4, 3, 2, 1, 0, right? So these spaces are going to be important. So when I said, my synthetic division, we're going to put 1, 0, 0, 0, 6, 25. What number is going to go here? You're going to solve this for x, and that's the value that's going to go here. You just put the 5. So you bring down the 1, 5 times 1 is 5, you add this 2 is 5, 5 times 5 is 25, you add this 2, 25, 5 times 25 is going to be 125, you add this 2 is 125, 5 times 125, 625. And so when you add this 2, and this is going to be my remainder, this is going to be 10, 5, 1250. So then we write my answer with starting with one exponent less than the original equation on the numerator. So 1x to the third power plus 5x to the second power plus 25x plus 125 plus 1250 over x minus 5. And that's what my answer is going to be. So let's see if we do have that answer. 5x squared plus 25x plus 125 plus 1250. Yes, right here. This is the same thing, doing synthetic division. So, but here, x to the third, x to the second, x to the first, no x. So I'm not missing any number to say that I need to put zeros anywhere. Here we're going to put a 2. Where am I getting the 2 from? Because remember that you're going to set this denominator expression equal to 0, and whatever value you get, that's the one that goes here. So then here I bring down this number. It's going to be 2 times -6 is -12. You add this 2, -10. 2 times -10 is -20. You add this 2, it's -15. 2 times -15, -30. You add this 2, -40. So -6x to the second minus 10x minus 15 minus 40 over x minus 2. So let's see, minus 15, oops, I moved this, sorry. So it would be letter B. This would be the one. Okay, they wrote it a little different here, but it's the same thing. Plus and then negative 40. Exact same thing. 19. Find the solution to the inequality algebraically or by graphing. Okay, honestly, I think the easiest way you could probably do this, let's see if with the calculator it's an easy thing to figure out. I would try to use the calculator if possible. Just be careful how you put this into your calculator. Okay, so we graph it. I don't think it's that bad to see it with to do it with the calculator. If you do it algebraically, it's gonna take you some time. So this would be the graphical way. Remember that we already that I went over this already. So this is my line that is going to divide the graph into two sections. Oops, sorry, because this is all crooked. You can barely see, right, because I'm covering this. There's this section that is above the graph and below the graph. And by the way, this piece, I know it doesn't look like that, but this piece continues going upward like this, okay? Like this. And there's this vertical asymptote right here that we don't see. It continues here. So, it says in here, greater than 0. That's what this part says. The function f of x greater than 0. So this is section 3.6, right? Very last one. So then, what part of the graph is greater than 0? This means above the x-axis. And so above the x-axis is this piece of graph and also this piece of graph. And that's it. Everything else is below the x-axis. So this piece from left to right, you're going to say this is above the x-axis, but from left to right, in terms of left to right. So this is from negative infinity up to what number would this be? And because again, as always, I was writing on top of the numbers. Now I cannot count. So 1, 2, 3, 4, 5, 6. So negative 6 kind of looked like that, but I wasn't too sure. Okay, and so union, and then you have this other piece that starts at, so at 6. I was trying to see the answer choices so that I wouldn't erase, but 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. Okay, so from 6, I'll do that right now again. From 6 to positive, to positive infinity. So that's what the solution would be. Those are the two pieces above, so negative infinity to negative 6, 6 to positive infinity, so this one right here. The other ones are different. Okay. This one says, graph the function showing all asymptotes. Those that do not correspond to an axis those that do not correspond to an axis, graph them as dashed lines, leave the x and y intercepts. So here we're going to do those 7 steps that we were doing once, where I'm going to try to see if I can remember the order, because I remember the steps, but I don't know if I'm going to do it in the same order necessarily, but if not, it's the same. Find what kind of symmetry we have. Okay, so is this going to be symmetrical with respect to anything? We'll see right now. So here, negative x times negative x is a positive x, so this is going to be a positive 7x, because negative times a negative is positive. So right here on the numerator, one term change of sign, the other one did not. So then this means that there's no symmetry. Then I remember the next thing was find the y-intercept. So how do I find the y-intercept? I replace the x's with a 0. So 4 over negative 4, it's a negative 1. That's my y-intercept. 3 was find the x-intercept. And so to find the x-intercept, I was supposed to put a 0 on the y and solve for x. X plus 4 over 2x squared minus 7x minus 4. So what I do is I multiply both sides by the denominator. So then these two cancel. Left side is going to be 0 because all of this multiplied times 0, it's simply 0. I subtract 4. So x is equals to 0 minus 4, negative 4. That's what my x-intercept is going to be. I just have one. 4 was finding vertical asymptote, or any hole, if there was any hole on the graph. Vertical asymptote, or any hole. Not every graph needs to have a hole. I mean, we'll just see. Or a vertical asymptote either. So, something that's important here is that if you see that there is any possibility for the numerator or denominator to be factorable, you want to do it. The denominator may be factorable. I'm going to do it here to the side because if it is possible, it's an expression that is factorable with several steps. Let me check that I put everything as it should be. Yes. Okay, so then to factor this, I open two sets of parentheses. X times x is x squared. Multiply the 2 times the 4. Wait, that's 8. And when two numbers are multiplied give me 8, but subtracted give me 7. So yes, it is factorable. 8 times 1 is 8, and subtracted is 7. Minus plus divide by the 2. The 2 that's at the front of the x squared. So x minus 4. This is 2x plus 1. So x minus 4, 2x plus 1. Okay, so it was important to factor the numerator and denominator, or any of them that could be factorable, because you see here these two expressions are going to cancel each other. So the reduced version of this is going to be 1 over 2x plus 1. And that's going to change things. So this, it's going to be the whole. The whole on the graph is x. Wait a minute. One was plus and one was minus. Let me see. Did I copy the signs correctly? Yes. Okay, so never mind. They're not the same. Just realized they're not the same. Sorry. No, we don't cross them out. Nothing repeats on the numerator and denominator. That's the only way that I would cancel. So then this has no holes. This graph has no holes, but it does have two vertical asymptotes. The vertical asymptotes would be x minus 4 equal to 0. Obviously solve for x. So this is one vertical asymptote, and this is 2x plus 1 equals 0. Obviously solve for x again. So this is the other vertical asymptote, x equals negative 1/2. Those two. Okay, but there's no holes. Okay, the next thing, which is step 5, is finding the horizontal asymptote, if it is that there is any. So for horizontal asymptote, we look at the degrees, the highest exponent on top and bottom. So the degree, let me rewrite the whole thing here. I'd rather do that. Um, 2x squared minus 7x minus 4. So highest exponent here is a 1 and here is a 2. So when the degree on the numerator is less than the degree on the denominator, then you have y equals to 0 as your horizontal asymptote. So your horizontal asymptote is going to be y equals to 0. Look up for your definitions in section 3.5. That's where we saw this. Every time that a problem has a horizontal asymptote, for sure it will have no slant asymptote. So I'm going to add here something on my own. No slant asymptote. When is the only time you're going to have a slant asymptote? When the degree on the numerator on top of the fraction is greater than the degree of the denominator by exactly 1 more. But that's not the case here. Okay, and so once you gather all this information, you're ready to do the graph, which is what this question was about. So I'm going to do my best to draw the graph here, even without a grid. So let me see, what things do I plot? There's no symmetry. The y-intercept is -1. X-intercept is just 1, -4. Is it -4 or 4? -4. 1, 2, 3, 4. So here is the x-intercept. Here is the y-intercept. What else we put? The vertical asymptote. The vertical asymptote is at 4 1/2. 1, 2, 3, 4. Okay, so there's an undefined place right there. And -1/2. There's a horizontal asymptote at y equals to 0. So this is x equals 4, x equals -1/2, and here okay, it says here that the x-intercept it's at -4. So let's see how this is gonna look like. That was another one. Okay, so let's graph this one just to see if we're on the right track. Wait. Parenthesis x plus 4. If I don't put parentheses, remember, with this kind of functions, it's not going to be correct. So this is one vertical asymptote at -1/2 at 4. Here is another one. Let's go to the table. At 4, it says that there is an error. Oh yeah, because that's where the vertical asymptote is. -4 says that there is a 0 and it's intercept. Okay, so I just wanted to check something out. So my vertical asymptote then is just my horizontal asymptote. It's simply affecting this side of the graph not this side, not the left side, because I can see that there's a point touching here the x-axis. And at y equals to 0, which was my horizontal asymptote, nothing is supposed to to touch or to cross through this line. Yet over here on the left side there's a point, so that's why I was looking to make sure that if on the table at -4 that was really a point, and it is -4, 0. It also looks like right here there is that horizontal asymptote affecting. We'll see right now if it, I think it doesn't cross this piece in the middle to this top part, but we'll see. So let me do a table of values here to the side. And all I want to do is get more points to do a better graph. So here is this, between this x-intercept and this vertical asymptote of -1/2, I'm going to choose a number at random. Let's look at the table. Let's choose, it says -1, 0.6. So -1, 0.6. Let's say this is 1. Does it make sense? Yes. This piece, you don't see it on the graph, but it's supposed to be this piece right here, although it's not a very good thing with this color. So I already have at least one additional point between the first x-intercept and the first vertical asymptote from left to right. Okay, so, and it's going to cross through the x-axis because I can see that there is an x-intercept right here. Okay. Then for the middle section, then let me choose a point here in this section in the middle. Whatever point you want. What do we choose? Do we choose 2 and -0.6? Okay, let's do that one. 2, 0.6. So somewhere here. If you see how this is gonna look, it's gonna look like this. So I don't know if you want to choose another point. Let's say 3. What's 3 going to be? 3 is -1. That's a good point to choose. 3, -1. So a little bit lower. And then we do this. Something like that. Okay. And then on this side, so this is 3, 4, 5, 6, 7. Let's say that I choose something after this x-intercept. Something after 4, obviously. So 5.8 and 6.4. Five and 0.8. 6 and 0.4. Something like that. Maybe that's good enough. Okay, and then you do this piece right here. If we were to zoom, let's say we zoom on the left side. See how this piece looks like. See, it looks like that. At -4, because like 1, 2, 3, 4, somewhere over here, it's crossing the x-axis. We don't see it because it's already too close to the x-axis. Okay. If I put it in the same format again, in the regular, you can see, for some reason this all calculus, it cuts always pieces on top or bottom in the rational function. I don't know why it does that. Now, I did all this question as if I wouldn't have answer choices, as if I need to do the entire graph. If you have answer choices, and if the answer choices are graph, why not graphing this simply and matching it to the right answer choice? You could do that. I just showed you the long way right now, and we reviewed the concepts. Find the solution to the inequality algebraically or graphing. Since you have the graph, why would I want to do this algebraically? It's way more complicated and longer. Let's do graphically. So, okay, graphically, this piece is telling me that this function whose f of x, this is f of x, I'm looking for f of x less than 0, so I'm looking for the pieces of the graph that are below the x-axis. Okay. So below the x-axis is from here to here, and then from here to here. And by the way, this is going to continue, remember, unless I see a dot. So for this piece, and I'm going to put them in different colors, this piece right here starts at which number? -1, -2, -3, -4, -5. So from -5 all the way to 2, then union, and then what's this piece going to be? Starts at 3, 4, 5, 6. 3, 4, 5, 6, yes. All the way to infinity, because it's going to move to the right in an infinite way. So this 2 would be my answer together. -5 to 2, 6 to infinity. So A, letter A. That's it. That's the answer. Okay. So f of x less than 0, you're looking for the pieces of the graph that are laying below the x-axis. The graph of a one-to-one function f is given. Sketch the graph of the inverse function on the same set of axes. Use a dash line. Okay, so simple. Get these 3 points, the coordinates of those 3 points that are right here. So this is 6, comma 2. This other one is -1, -1. No, 0, -1. And this one is -5, -5. So remember that the inverse of a function, it's nothing more than switching around your x and your y, right? That's one of the steps when you're finding the inverse of an equation. So what's going to be the inverse of this? Switch your x's and y's from place. 2, 6, -1, 0. And this one, it's just the same point itself, right? So these are the inverse. The points that are going to form the inverse function. 2, -6, -1, 0. 2, not, wait, -6 is 2, 6. Sorry. 2, 6. So up here. -1, 0, and -5, -5. Which is this same point itself. So we connect this 2, we connect this 2. Sorry that the lines are all crooked, they're supposed to be straight lines, right? And so how do I know that I did this right? Because if you draw a special line that is y equals x that passes through points that have the same x and y coordinates, ask yourself if these two look as a mirror image across this line y equals to x, and they do. I know my lines are all crooked, but if I would have a ruler and I could do this better, it would look as a mirror image. And me, as a matter of fact, try to do this a little better. -1, 0, 2, 6. If I would do the lines with this, maybe it's gonna be better. Let me do this one again. Kind of. I don't know if I did it worse, but I mean, that's more or less the idea. So this piece is a reflection over here, and this piece is reflected over here. So they do look as a mirror image, and that's the idea of the inverse. You switch the x and y from place. Don't change any signs, just switch x and y from place. This one says that this is the graph of a function, and you have no formula for f. I mean, that's just what's given to you, and you want to graph the transformation of it. So something like what you did on the test, you're going to collect the points, and you're just going to be doing the changes as suggested on the transformated equation. So then this is going to be -4, 0, 2, 3, -3, 2, -2, 2, 0, 0, 3, -1, 4, 0. So I just copied the points, the coordinates of this point. So 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, okay. Have the same. So here, this plus 1, it's going to be 1 unit to the left. So when I'm moving a graph to the sides, to the left or to the right, I'm either adding or subtracting. So if I have within a grouping symbol a parenthesis, in this case x plus 1, I'm going to do the opposite of the plus. I'm going to subtract. In this case, you're going to subtract 1 from the x's. So from all these x values, I'm taking away 1. That's what I'm going to do here. This is not very straight. Let me see if I can do it better. Okay. Okay. So -4 minus 1 is a -5. This is -4, -3, -1, 2, 3. These ones are the same. Okay, the next one, the next transformation, and I'm going to be doing them in the order as I should. There's two things. There is a reflection with the negative across the x-axis or over the x-axis. The x-axis, but that's the negative. Now with the positive 2, there is a make this longer. With the positive 2, there is a vertical stretch by a factor of 2. So whatever you decide to do, if you look at your chart, on the formula chart, when you have a reflection of the x-axis, what you're supposed to do is multiply the y times a -1. And then when you have a vertical stretch, you're supposed to multiply also the y's, but by 2. So the order of these two things doesn't really matter. If you want to do the reflection first, times -1, or you want to do times 2 for the vertical stretch, it doesn't matter. It's the same thing. So let's say that you do times -1, times -1, times -1. So you're going to do the reflection first. But it would not affect if you do first the if you do first the vertical stretch, it would be the same thing. So here, 0 times -1 is 0. This is going to be a -2, a -2, a 0, a 1, a 0. Then here, in the next table, I'm going to multiply the y's times 2. So then here, 0, -4, -4, 0, 2, and 0. And to finish, the -3, which is, sorry, here was 1 unit, right? Didn't put the 1. 3 units to the, no, down. So here, what we're going to do is we're going to subtract 3 to every y. -3, -7, -7, 3, -1, and -3. So these are the final points that I'm going to plot over here on the coordinate plane. I'm going to put -3 and -3, -4 and -7. -3 and -7 as well. -1 and -3. 2 and -1, and 3 and -3. I was looking at the graph, and this was a -5, and I wrote it as a -5, but when I read it again right now to plot the point, because I wrote it very tiny, I thought it was a -3, but it's a -5. So the point where I plotted at -3, -3, this one, it's not supposed to be that. It's supposed to be -5, -3. So -5 is right here with -3. That was the first point. And then -4, -7, and then -3 and -7, and then -1 with 3, there, and then 2 -1, and 3 -3. Okay, I think it makes a little bit of more sense. I hope I can do straight lines. So from here to here it's one line. This one, it's a tiny line between these 2 points, and then it goes from here to here, and then from here goes like this, and then here. Okay. So there it is. That's my transformation. Okay, so there's the graph. Next one. Choose the graph that satisfies the given conditions. Degree 3 with 1 x-intercept positive. Okay, so I did not copy for this one. What's 24? Okay, let's see, 24. Because this one, unless I have the answer choices, I mean, they don't give us a lot of information so that we can come up with the answer and say, oh yeah, this is it. I mean, guess we're just gonna have to use the answer choices. So degree 3 means that, why are they telling me the degree is 3? Because when the degree is an odd type of degree, remember that the endpoints are gonna be going in opposite directions. So it could be like this or like this, but they're gonna be in opposite directions. With 1 x-intercept and a positive leading coefficient. Okay, so a positive leading coefficient, it's going to be this. Positive, and this is a negative. I'm going to abbreviate LC. And LC here. So then, right now, we are saying that our graph, according to the degree being an odd degree and the positive leading coefficient, because of those two things, it has to end like this. So it cannot be letter A because it's both pointing upward, cannot be letter B, both pointing downward. And just with this thing, with that thing by itself, we can tell already which one of these two is going to be. But plus it says with 1 x-intercept. So that means it crosses the x-axis only once, and anyway C and D cross the x-axis only one time. A and B were crossing 2 times each, so that's why another reason those couldn't be. So then it's going to be D, right? So this is an easy one, just knowing the concepts, right? The definitions. Give all possible rational zeros for the polynomial. Possible rational zeros, okay. So we're not going to find the actual zeros, the actual answers. They just want the possible ones. That's why you're going to use the rational zeros theorem. So what's P? It's 18. What's Q? It's the 2. Now, do you need the negative? No, just the 2. So then, numbers that 18 is divisible by 1, 2, 3, 6, 9, and 18. And this is divisible by 1 and by 2. So when you do P over Q, you're going to do 1 through 18, 1 through these numbers that I put here between 1 and 18 divided by 1, and then these numbers again 1 through 18 divided by 2. Any repeated number, you're not going to write it twice. 1 divided by 1 is 1, and then 2 divided by 1 is 2, 3 divided by 1 is 3. Okay, so 6 divided, I wanted to make the arrows smaller so that I could show you how I'm going to divide all this by both numbers. But let's see if I can. So 6 divided by 1 is plus or minus 6. 9 divided by 1 is plus or minus 9. 18 divided by 1 is plus or minus 18. Now I'm going to continue here, but now all these numbers by 2. So 1 divided by 2, and I'm going to continue in the same list, plus or minus 1/2. 2 divided by 2. It's not that I'm not dividing 2 by 2, but 2 divided by 2 is 1, and I already had it at the very beginning of the list, so I'm not going to repeat the same integer. 3 divided by 2 is a number that I don't have in the list, 3 halves. 6 divided by 2 is 3, I already had it, so I'm not going to use that one. 9 divided by 2 plus or minus 9 halves, because I don't have that one. And 18 divided by 2 is 9, and I already have a 9, so I'm not going to write also that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So which answer? 9 numbers, but I mean each one is positive and negative, right? So it's more than one. But which one is the right one? B? Yeah, B is the one. So those are the possible rational zeros. Solve the polynomial equation in the complex numbers. Okay, so here is where you're going to do that long process with the synthetic division and all that. Okay. So we're going to start by finding the possible zeros. Okay. So my P is 26, my Q is 1. So this is divisible by 1, by 2, by 13, and by 26. And this is just divisible by itself, by 1. So when I do P over Q, plus or minus 1, plus or minus 2, plus or minus 13, plus or minus 26. I just divide all these numbers by 1. That's basically what I did. So what do I do now? Synthetic division. With what number do I do synthetic division? First, whichever number you want. Shortcut. I already showed you in class the shortcut, so you don't waste a lot of time figuring out the first number. Put the equation in your calculator. X to the third minus 2x squared plus 5x plus 26. You just need to find one number from this list that's an x-intercept. Could be -2 to be on the safe side. Let's go to the table. Yeah, -2. That's all I need. One number that is an x-intercept. So how did I know that it was -2? Because it has a 0 on the y-coordinate. That's an x-intercept. That's a solution. That's a 0, however you want to call it. So then here inside I copy the coefficients 1, -2, 5, and 26. So I bring down the 1, -2 times 1 is -2, -4, +8, and I multiply this 2, this is going to be 13, -2 times 13 is -26, and I get 0. Perfect, because if I don't get 0, I did something wrong. It has to give me 0. So I write an equation starting with 1 degree less, or 1 exponent less than the highest exponent here. So the highest is x to the third, so this is an x to the second minus 14x plus 13, and you equal it to 0. Now we want to find, so you see here on the graph it only looks as there is one x-intercept, that it's a real number, a real x-intercept. The answers that I have in the answer choices are complex numbers. Look at these answers. So all of them have the -2, right? -2 comma, -2 comma. So I need to figure out the other complex. I'm going to see if I could factor this. I don't know if it is factorable, but it may be. If not, worst case scenario, I use quadratic formula. So x times x is x squared, 13 times 1 is 13, and added it's 14. Perfect, it works. Minus and minus again. So x minus 13 equals to 0, x minus 1 equals to 0. So x is equals to okay, I just saw a careless mistake, and I'm like, this is coming out really nicely, and the answers are not supposed to be nice numbers. Look at what I did here. -4. I put a -14 here, I think it was my subconscious that I didn't want to work with complex numbers or something. So, sorry. But it was a -4 and not a -14. I don't know where I got the 1 from. So when I try to factor this out, it's not going to work out because there's no two numbers that multiply give me 13 other than 1 times 13 that added equal to 4. So then I'm going to use the quadratic formula. Negative b plus or minus b squared minus 4 times a times c divided by 2a. I was already making it super easy for me. Okay, so then that's my a, my b, and my c value. I have negative b, it's a -4 plus or minus b squared, which is -4 squared, minus 4 times 1 times the c. And 2 times 1 on the denominator, so it's going to be a negative times a negative, it's a +4. -4 squared is 16. -4 times 1 is 4. -4. -4 times 13 is going to be negative 52 over 2. So 4 plus or minus, here 16 minus 52 is going to be a negative number. Square root of -36 over 2. So 4 plus or minus, square root of 36 would be 6, but because it has a negative inside, you're going to put a 9 next to it. So we divide by 2, by 2, and by 2. 2 plus or minus 3i. That's it, because 2 divided by 2 on the denominator is a 1. You don't need to put over 1. Just leave it like that. So then these are my two complex numbers that I was looking for. 2 plus 3i, 2 minus 3i. So 2 plus 3i, 2 minus 3i. So it's letter B. The -2 that I had found here when I did the synthetic division for the first time. 2 plus 3i and 2 minus 3i. Okay, the next one is the same problem. I mean the same type, right? So P is 18, Q is 1. So 1, 2, 3, 6, 9, and 18. And this is just 1. So we do the synthetic division, at least we set it up. Oh, and I forgot to do the plus or minus, right? But you know, it's just going to be all these numbers divided by 1. I mean, it's the same as all the values in P, but with a plus or minus. There. Put it on the calculator to save time. X to the 4th plus 4x to the 3rd minus 9x squared minus 30x minus 18. Okay, one of the x-intercepts, there's several ones. One that I see here, I think it's -1. If that is the case, yes, -1 has a 0 on the y column. So then I'm going to use that one, -1, 1, 4, -9, -30, and -18. Okay. So then I bring down the 1. -1 times 1, it's a -1. I add these two numbers, it's 3. Negative 1 times 3 is a negative 3. This is going to be 10, 11, 12, negative 12. Then this is 12. When you add this 2, this is going to be negative 18. Negative 1 times negative 18 is going to be positive 18. And so this is 0. Perfect. So we're on the right track. Now we are going to write one equation of 1 degree less than the original equation. So this is 1x to the third plus 3x squared minus 12x minus 18 equal to 0. Every time that your highest exponent is not yet at 2, like here it's a 3, you need to repeat synthetic division. Now, the question is, so am I supposed to do synthetic division again with this same number or with a different one? Well, that negative 1 had an even multiplicity, right? It's touching and turning around on the x-axis. So it's okay if I use it again. I could use it again. We do negative 1, but now I'm going to use the new coefficients from the new equation. I don't use the same ones anymore. If this x-intercept was an x-intercept that is crossing the x-axis, I would have to be using a different x-intercept. Here I had two choices. Either I use a different x-intercept or I repeat the same one simply because it has an even multiplicity, because it's touching and turning around. If it was crossing, definitely I cannot repeat it again. I would have to use a different one. So I bring down this 1, negative 1 times 1 is a negative 1. I add these two numbers, and that's going to be 2. Negative 1 times 2 is a negative 2. I add these two numbers, and that's going to give me, okay. So I tried reusing it again, but see what's going to happen here. This 2 is going to be negative 14. When I multiply negative 1 times negative 14, this is 14. So what happens here is that I don't get the desired number here at the end, which is 0, right? I get a negative 4. And that tells me that even though I try to reuse the same x-intercept, I didn't get the same remainder, so I cannot reuse it in this time. I have to use a different one. So let me give you a tip. When you have the graph already on the calculator and you see that there's several different x-intercepts, then don't reuse. If you have several, don't reuse any of them right away, because this is going to happen to you. You're just going to waste time to realize that it's not going to work out to give you a 0 on the remainder, and you're going to have to do again. So I'm not going to erase this. I'm just going to put an X so that you remember that if you have multiple x-intercepts, different ones, choose another one. Like for example, I think it's crossing at 3 here. 1, 2, 3. Let's see if it is 3. Yeah, right here at 3, there's an x-intercept or another solution. Okay, so sometimes remember that there are problems where you do reuse it, and there are some problems where you won't reuse it. So here, I will not reuse it because I tried it, but it didn't give me a 0 on the remainder, and I made sure that I didn't do any careless mistake. So that meant that I had to use a different x-intercept, and there was different x-intercepts that I could have used. For the second time that I'm going to do synthetic division, and I'm doing synthetic division a second time for the purpose of lowering the degree here. The highest exponent on the next equation is going to be a 2, and that's what I wanted. So I bring down the 1. 3 times 1 is 3. You add this 2 is 6. 3 times 6 is 18. When you add this 2, you're going to get 6. And 3 times 6 is 18. So when you add this 2 is 0. That's what we wanted. So we write a new equation, 1 degree less than the previous one. So this is an x squared plus 6x plus 6. You equal it to 0. And let's see if we can factor this. And if it is not factorable, quadratic formula. X times 6 is x squared. For 6, we want two numbers that multiply together gives us 6, but added together also gives us 6. And I don't think that's possible. because there's only 1 times 6 and 2 times 3, and it's not going to work out. So because it's not factorable, we're going to have to use the quadratic formula. So x equals negative b plus or minus b squared minus 4ac divided by 2a. A is 1, b is 6, c is 6. Negative 6 plus or minus 6 squared minus 4 times 1 times 6. 2 times 1. 6 times 6 is 36. Negative 4 times 1 is negative 4. Negative 4 times 6, negative 24 over 2. So 36 minus 24, that's going to be 12. 6 and yeah, over 2. So 12 does not have a perfect square root. We're going to practice again that method of factoring a number that doesn't have a perfect square root. So then what you do is you say, make the list of the first perfect squares all the way up to 12. Up to wherever you see 12, it's more or less. So 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square is 25. Excuse me. I was sneezing. Okay. So 12 is between these two. Right? So between 9 and 16. So you're going to observe the list prior to where you have located where 12 would be. So then, which of these numbers from 9 and before, which of these numbers is 12 divisible by? Find the greatest one. And it's only divisible, I mean it's divisible by 1, but it's also divisible by 4, and that's the greatest. It's not divisible by 9. That's the greatest that it can be divided by. So 12 is divided by 4, and the answer is 3. So that means 3 times 4, or 4 times 3, the order in how you write this, it doesn't matter. It's the same as 12. But 4 has a perfect square root. So in the next step, you're going to take that outside. Square root of 4 is 2. You leave the 3 inside. Divide by 2. Divide by 2. Divide by 2. Negative 3 plus or minus the square root of 3, because 2 divided by 2 is 1. And 2 divided by 2 is also 1 on the denominator, so you don't put over 1. So these are my two answers. Negative 3 plus the square root of 3, negative 3 minus the square root of 3. So in total, how many answers did I have? I had negative 1, I had the 3, and I had this one too. So I'm going to put them all here. Negative 1, 3, negative 3, plus or minus the square root of 3. So in reality, I have 4 different answers. Let's see. Negative 1 and 3, right? First of all, it was positive 3. And what was the last one? Negative 3 plus the square root of 3, negative 3 minus 3. So it's B? Yes, it's B. Okay, find a polynomial function. So this is a different question. Find a polynomial function of lowest degree, leading coefficient of 1, and with the zeros given below. Okay. So these are the zeros. X equals 2, x equals negative 10, x equals 4 plus 3i. And if you recall, when we did this problem, or when we went over this section that had this kind of problem, I told you that you need to come up with the conjugate or the pair of the complex number that has an I that has been given to you, where the pair over the conjugate of this is going to be changing the sign on the number that has the I, not on the other number, and not on the other numbers that don't even have an I. Okay, the leading coefficient is going to be 1, so that's good. At the end we don't have to multiply times anything, and so when I send this 2 to the left side of the equal sign, it becomes a -2, and I equal it to 0. When I send this -10 to the other side, it becomes +10. When I move this one here, the 4 and the 3i to the other side becomes minus and minus, because both were positive, so they became negative. And here, the 4 became a negative, but the -3i became a +3i. So what I'll do next is that I'm going to copy the factors. The factors are going to be just the expressions that are before the equal sign. And I'm going to multiply them together. So these two together, x times x, x squared, x times 10, 10x. -2 times x, -2x. -2 times 10, -20. I'm going to multiply the conjugates together. Remember that one key thing on this problem that I told you is that the conjugates, they must be multiplied together. Otherwise, we're going to do a big mess, and we're not going to be ever able to be, we're never going to be able to get the answer. So x times x, x squared, x times -4, -4x. X times 3i, 3ix, or 3xi. Where you want to put it. -4 times x is -4x, -4 times -4 is +16, -4 times 3i, -12i. -3i times x, -3ix. -3 times -4, +12i. And -3i times +3i, -9i squared. Then we simplify. We combine these two like terms, so -12x, I just bring down the -20. Let's see what things we can combine over here. So -4x can be combined with this -4x to make a -8x, right? Then +3xi cancels with the -3xi. Also, -12i plus 12i cancel. All of those terms with ix or with the I by itself, they need to cancel. If they don't, we didn't multiply correctly the conjugate. Okay, plus the 16, there's nothing that I can combine the plus 16 with, minus 9 times a -1. Remember that at some point I told you that every time you had an I square, that I square was going to be replaced with a -1 in this kind of problem. Always, you have to do that. In other words, you want not to end up with any term that may have an I at the end. Here you're going to multiply -9 times -1, +9. So here x squared minus 8x, and then when you add this two, it's gonna be 19, 20, 21, 22, 23, 24, 25, plus 25. And obviously we multiply these two parentheses. So x squared times x squared, x to the fourth, x squared times negative 8x, negative 8x to the third, x squared times 25 plus 25x squared. Negative 12x times x squared, negative 12x to the third, negative 12x times negative 8x, positive 1696x squared, negative 12x times 25. Okay, that's going to be a negative that's going to be negative 300x. Negative 20 times x squared, negative 20x squared, negative 20 times negative 8x, positive 160x. And negative 20 times 25, negative 20 times 25 minus 500. X to the fourth, this x to the third with this x to the third, so a negative 8x to the third, and then negative 12x to the third, you add them up and it's a negative 20x to the third. Then we have 25x squared, 96x squared, and negative 20x squared. You can put them all in the calculator if you want. 25 plus 96 minus 20, 101. Positive 101x squared. Then we have negative 300x and 160x. So 300, well, it's negative 300 plus 160, negative 140. Negative 140x minus the 500. And this is my polynomial. Hopefully I did not do any careless mistake, and the answer is right there. If the leading coefficient would have been a different number, that it's not a 1, I would have to multiply the entire polynomial by that number. But in this case, I don't think we have to do that because the leading coefficient was 1. So x to the fourth, oh my god, I don't find any minus 20x to the third. So I must have a careless mistake somewhere. Let's see where that's going to be. Yep. Okay. Let me try to backtrack where I did a careless mistake. And hopefully I didn't copy anything incorrectly since the very beginning. Okay, X, let me really quick go back and check, okay? I just saw it, and it is at the very beginning. Okay. Sorry. Here, where I was doing the first set of multiplications, x times x, x squared, x times 10 is 10x, negative 2 times x is negative 2x, negative 2 times 10 is negative 20. When I combine these two, 10x minus 2x, they were not negative, both. So it was positive 8x. That's the only careless mistake that I have found so far. So then this to positive 8x. Hopefully that's the one that is gonna fix everything. This one, it's also positive 8x. So x to the fourth, negative 8x to the third, 25x squared. So here's gonna be the first change. This is supposed to be a positive 8x positive 8x to the third power, and then here it's supposed to be a negative 64x squared. Negative 64x squared. When I did this two in the middle, here at the end it's also a positive 8 times 25. Positive 200x. Okay, 20x squared. The rest are correct. Okay, so in the combining this one with this one, they were going to cancel. These two, they were going to cancel out each other. So there was no term that was going to be raised to the third power. The x squared is 25 minus 64 minus 20. 25 minus 64 minus 20. Negative 59. There it is. I think I remember one of the answer choices being like that. Minus 59 x to the second. So this term is not right. What else? The x's to the first, 160 and 200. That was fine. Minus 140x and minus 500. Okay, let's check again with the answers. X to the fourth minus 55x squared. There's only one that is like that, and that's letter C. Let's check the rest. Oof, but the second number over here. So I got this two already, but this, the minus 500 is right, the plus 360. Oh yes, because I changed this term to a positive 200. It used to be a different number. Plus 360x. When you add this two in black. So there it is. It is, sorry guys, it's letter C. You probably saw it since the very beginning when I combined these two terms over here. So sad that you cannot tell me because you cannot speak to me right now. Okay, so moving forward with the next one, the next problem. It's the same instruction, I guess. Yeah, the same instruction. Let's just find the polynomial function of lowest degree, leading coefficient 1 with the zeros given below. So then here my zeros are given negative 3i, so I need to remember that there exists the conjugate of this, and x equals 4. So x plus 3i, when I move the negative 3i to the other side, I don't know why I put an equals. X minus 3i, when I move it to the left side of the equal sign, and I keep on doing the same thing, x minus 4 equals to 0. So then f of x is equals to x plus 3i, x minus 3i, and x minus 4. Conjugates always together. So x squared times x squared times negative 3i, negative 3ix, 3i times x, positive 3ix, 3i times negative 3i, negative 9i squared, times this one. I'll do the multiplication times x minus 4 at the end. So x squared, these two, they're going to cancel, minus 9 times a negative 1 because of the I squared. X squared plus 9 times x minus 4. X to the third power minus 4x squared plus 9x minus 36. Okay, so this one's so much nicer and shorter. Hopefully it didn't do a curl mistake. Let's see. X to the third minus 4x squared plus 9x minus 36. No, perfect. So it was A. The other one was too crazy. Okay, next question. Use Descartes' rule of signs to determine the possible number of positive real zeros and negative and the possible number of negative real zeros of the function for the function. So for the positive ones, remember that I told you you're gonna count the signs as they are. As they are given to you on the polynomial. So from the first term to the second term there is one sign change. From the second one to the third one, nothing. From the third one to the fourth one, yes, there is one. From the fourth one to the fifth one, there's another one. So it's 3, or remember that if you can subtract 2, you'll do it, or 1. Positive 0. And then for the negative, you're supposed to put a negative x into every x So instead of you doing negative x and multiply that negative x by itself 20 times, remember that I showed you once the even and the odd shortcut. So if you're even, if you have an even exponent, the answer is going to stay positive. If you have an odd exponent, the answer is going to be negative. So negative x to the 20th power stays as a positive x to the 20th. And with the sign of the 3, which is positive, positive times the positive stays positive. So the whole positive from the x to the 20th times positive from the 3 makes a positive term, 3x to the 20th. With the next one, it's also going to be a positive x to the 14 because the 14 is even. The issue here is there's a negative on the 6, so positive times the negative, negative 6x to the 14th. Even if the x to the 14th was positive. Times the negative in front of the 6 makes it negative. This is going to stay as a negative x to the 11th times a negative on the 2, positive 2x to the 11th power. Negative x to the second stays as a positive. And here, this one stays as it is because it's raised to the first power, so this is a negative x. Negative x times a negative 5, positive 5x. So from here we count the sign changes again. From the first one to the second one there is one sign change. Second one to third one there is again one sign change, so that's the second one. And then from there and forward there's no more sign changes. So the maximum is going to be either 2 or, and because I am able to subtract 2 or 1, negative zeros. Okay, determine which of the rational functions given below has the following features. Okay, so this is a good question because it's going to be a review of section 3.5, and it's backwards. We were used to be given the equation and you had to do the graph. Well, now it's backwards. They're going to give us some characteristics and we have to figure out which equation has those characteristics. So you could use the calculator, but you could also do this by hand just to review the concepts. So there is a hole in its graph at x equals 2. So that means that whichever equation I say is the answer, there needs to be one where if the hole is supposed to be x equals 2, think when you put this as an expression here as a factor. This number, when it moves before the equal sign, you form the expression x minus 2. And I'm writing it on purpose going backwards, like upwards, because I want you to see that, okay, if I get this, I write it equal to 0, like this, and I would solve for x, I would go back to this expression x equals 2 because I moved the minus 2 to the other side by adding. So my expression needs to have an x minus 2 at the bottom and an x minus 2 at the top. Why? Because it says that that is the whole, and the whole is supposed to be an expression that is repeated on top and bottom. That's all they're telling me, that I need to have one that has the same expression repeated on top and bottom, and it has to be this exact expression. No other expression repeated. You may have other one repeated, but for sure I need to choose one that shows that. So that would be the only one that I see that has that repeated. It's D, right? So that would be the one that has a hole at x equals to 2. It's not going to be this one because the hole on this one, when you work it out to solve for x, you get negative 2, which is not the hole that they're giving you here. Next question. Determine which rational function, so yeah, which of the answer choices are of x has a graph that crosses the x-axis at negative 1, touches the x-axis at negative 4, has vertical asymptote at x equals negative 2 and x equals 3, and has one horizontal asymptote at y equals 2. Okay. So, let me think. Crosses the x-axis at negative 1. Okay. The x-intercepts usually are the numerator of the rational function. So if there is an x-intercept, because it says that it crosses the x-axis at negative 1, it crosses it at negative 1. But when you write that expression here, you're not going to put x equals negative 1. You need to write an expression that is set equal to 0 where this number moves to the other side. So there needs to be an x plus 1 on top, and this is my x-intercept equal to negative 1. That's this part. Touches the x-axis at negative 4. Okay, so touches, that talks about another x-intercept. But when you move this here, this is going to look as x plus 4. But what's the difference if it touches, if it crosses? It's talking about the multiplicity. Here the multiplicity can be 1 because it's crossing. Here it's saying that it touches at negative 4. So the multiplicity has to be an even number. So I'm going to put a 2, which I see the answer choices, some of them have a 2. So the 2 needs to be on the x plus 4. A, it's already out of the question because it doesn't have a 2 on the x plus 4. C has it. Has also the x plus 1 that is raised to the first power because I don't see any exponent. Could also be letter B so far on the numerator. D, no, because it has weird numbers on top. It has nothing to do. Has a vertical asymptote at negative 2 2, and 3. So this was an x-intercept. This is also an x-intercept. So this is an x-intercept of -4. The vertical asymptote, it says that there is one at -2. I'm going to write the other one here. And one at 3. So this is x plus 2 equals 0. X minus 3 equals 0, following the same logic as over here. So x plus 2, x minus 3. Doesn't matter which one you write first. The order does not affect the answer at all. And has one horizontal asymptote at y equals -2. The only way that the horizontal asymptote can be y equals -2 is because we need to have the same degree on top and bottom to divide the leading coefficient. So if the degree here on the top is already, if you add this exponent and this exponent, or this x raised to this exponent and this x raised to this exponent, as this x to the first times x to the second to come up with the degree on top, this is an x to the third. I need over here on the bottom the degree to also be an x to the third, so that the degrees are the same on top and bottom, and I can divide the leading coefficient. So I can decide where I want to put the 1 and the 2 at the bottom. Could be a 2 here or a 2 on this one, doesn't really matter. But looking at the answer choices, and I can already tell which is the right answer, because look at this denominator, has different signs. Has to be this one. So we're gonna go with putting the exponent there, although it could also be on the x minus 3. On the denominator, it really does not affect anything at all. Now, if I want the horizontal asymptote to be y equals -2, now that the degrees are the same on top and bottom, right? And where am I going to get that -2 from? Well, that's why on C you have a number here, -2. So that when you divide this -2 over this 1, that's your horizontal asymptote of y equals -2. So the answer here would be C. Find a rational function that satisfies the given conditions. Answers may vary, but try to give the simplest answer possible. Okay. So vertical asymptote. So it's the same thing. We're just practicing the same strategies. So vertical asymptote of x equals 4. So I'm going to put x plus 4 here. I'm going to do it a little bit faster because I know vertical asymptotes are supposed to be in the denominator. X plus 3. I'm switching the signs, right? There's horizontal asymptote of y equals -7/2. So there has to be a -7 on top and a 2 here. Okay. And how do I know that the top is a negative? Because I'm seeing the answer choices, right? So it cannot be C because there's no negative on top and bottom. Can be just because of the -7/2. It could be any of those. The x-intercept says that it's 1, 0. So the x-intercept being 1, 0 means that the x-intercept is x equals 1, right? This value right here. And I already know that this, in the format of a factor, here, it's gonna look like that. So I put x minus 1. That's my x-intercept. Now you may say, nothing from here looks like that. Well, it's because they distributed. They didn't leave this as you see it. So they multiplied this and this and this and this. -7x plus 7 On the denominator, you can do 2 times this, 2 times x, 2x, 2 times 4 is 8, and then oh, and you may be asking yourself right now, where is this exponent 2 coming from? Remember that in order for me to divide, to have a horizontal asymptote at a number like this, it's because I divided the leading coefficients, and I cover the x from the x. I divided the leading coefficients, and the only way that I divided the leading coefficients is because the degree on top and bottom are the same. But I'll take care of that right now. I'll leave this as it is, even though I know this is not the same as any numerator. So this is going to be 2x to the second. I'm going to FOIL the denominator. Plus 6x plus 8x plus 24. Two x squared plus 14x plus 24. Let's see. Is there any denominator like that? Okay, so then b is out of the question because the denominator is different. These two have the same denominator. What's the difference? The signs, and then there's an x on the 7 at the end that I don't have. Okay. So this is, the denominators are not the same on top and bottom. The highest, the degrees on the denominators. The degree here is 2. The degree here right now is 1. So that means that I should have added another one of this. And here, when I FOIL this, so this is going to be negative 7x and positive 7 times x minus 1. Sorry that it looks that I'm doing it backwards. It's not that I'm doing it backwards, but until I realized this, I went back and I'm like, okay, so this is what I need to do and change to make the degrees the same. And I'll simplify. I already did it over here. Okay, never mind. So, yes, you need to kind of work this by parts and not think that the first time you're going to get the full answer complete, because there's so many characteristics playing a role here that you need to go piece by piece and take care of one thing, and don't stress about getting all the things right at the same time or at the first time. Okay. Negative 7 times x, negative 7x squared, negative 7x times negative 1, positive 7x. 7 times x is positive 7x, and 7 times negative 1, negative 7. Okay, let me see. Positive 7x. Okay, the only thing that I'm not quite sure what happened, how is it that on the numerator they obtained this? Okay. Let's work it out backwards then. Negative 7x squared plus 7x. I'm just taking at random this expression, and then I'll do the same thing with this. I want to see, like, if I solve for x, we get minus 1. Okay, sorry guys that I'm thinking a little bit. But see, if I take this expression on the numerator, on letter A, and I solve for x, this is going to be one x-intercept, and this is going to be another x-intercept. This is x equals 1, right, when I solve for x. This is going to be x equals 0. So, on letter D, I'm also going to have two x-intercepts. One is going to be 0, one is going to be positive 1. The thing is, like, they're not mentioning to me that there is more than one x-intercept, but I guess they're just trying to confuse us. So it says, find a rational function that satisfies the given conditions. Answers may vary, but try to give the simplest answer. So there's more than one way to write the numerator. Since we have answer choices, we have to stick to what it is. There's this two vertical asymptotes, there's this horizontal asymptote, and there's this x-intercept. And nowhere here it says that there's only that x-intercept. There may be more, and there has to be more, as a matter of fact, because of the expressions that are given here as the right answers. Anyway, the one that would have the correct x-intercept, I think, is going to be A, because look, when I solve for x, x minus 1, when you solve it for x, this is the only one that's going to give you x equals 1, as in here. If you do this one, if I would do this one, let's see, negative 7x squared minus 7x equals 0. You factor a negative 7x, you put an x here, but then if you want a negative here, then this one has to be positive 1. And so when you solve this for x, this is going to be negative 1. See, and that's not the x-intercept that you have here, so no, this is not what you want. Therefore, this is not the answer. The answer has to be this one. For the numerator, the way that they created this problem, I mean, we don't have to be exact on the numerator. We just need to find one that has those characteristics, and the one that has all the characteristics that we said, it's A. At least the denominator, I got it to be the exact same thing, but the numerator, that's why it says that answers may vary. So how they came up with this exactly, not too sure, but I know that if you factor that expression on the numerator, this one, that's the one that I was doing, you do get the x-intercept as they're saying, but they were not thinking that there's another x-intercept and they didn't mention it. I'm thinking they were just trying to confuse us. That's what I'm thinking, honestly. Okay, so that is basically how to figure this one out. What is another thing you could do? You could graph them, put in parentheses on the numerator and on the denominator. You could do that too. Like, for example, if I'm saying this is the answer, look, parentheses negative 7x squared plus 7x divided by 2x squared plus 14x plus 24. Vertical asymptotes at negative 4 and negative 3. Okay, you can see them right there. Horizontal asymptote at y equals negative 7/2. Okay, so at negative 7/2, there has to be a horizontal asymptote. You don't see, but I mean, we don't see it, but there's a piece over here of the graph. Let's see if I do window, the y maximum, I'm gonna put it at, no, the y minimum, I'm gonna set it at negative 30. The x minimum, I'm gonna set it at negative 20, double of what we see. See? So the fact that this graph is curving here tells me that the horizontal asymptote negative 7/2, which is negative, negative 3 point something, right, negative 3.5, it's going to be right here, because that's where this is going upward and turning right here at negative 3 point something. We could assume more or less the x-intercept being 1. You can check the table. If it is not very clear, it looks like, yeah, it could be. But we can go to the table always. Check at positive 1. See, here is one of the x-intercepts, but see, that's not the only one. Even with this one, that's what I was telling you, there's this other x-intercept that they're not mentioning. So they're just making this question kind of tricky, but I mean, the information is there. You can just basically look on the table for the x-intercepts, looking for to see if those x's they're giving as being the x-intercepts, those x values have a 0 on the y, and check on the graph if it makes sense that there may be a horizontal asymptote what they're saying. If you see a graph approaching that number, that approximation of the number, and if it is turning or something like that. Check for the vertical asymptotes, they're there. So that's the same thing you could have done for this one. Put them on the calculator and figure out which one has those characteristics. But I also wanted to do it by hand so that we could review this concept. So moving on, 34. Use the graph to answer the question. Find the horizontal and vertical asymptotes of the rational function graph. So the horizontal is at y equals 2. It's this one, the horizontal. And the vertical, this one right here, it's x equals 3. So it's just a matter of knowing that horizontal is the y, vertical up and down is the x. So what answer is the right answer for that? Y equals 2, vertical asymptote at x equals 3. This one, find the domain and range of the rational function graph. Domain. The domain is going to be given in two pieces. This piece and this piece that are not connected. So from negative infinity up to the vertical asymptote 4, not including it, and then from 4 to infinity. The range is starting at 0. Looks, even though I don't see anything, that both pieces are turning here at the x-axis, so maybe there's a horizontal asymptote at y equals 0. Even though they're not telling me, I'm thinking that there is a horizontal asymptote at y equals to 0 right here, because I don't see the graph crossing below. So then from 0 to infinity. That's what I would say. So let's see. Is there one really like that? This one? And this concludes the review.